The last type of probability we are going to look at is known as conditional probability. And this type of probability is not actually explicitly discussed or introduced in your textbook, but is one of our sort of learning standards in college math, and is actually a sort of an important probability to understand. So we're going to sort of look at it, and then there's some extra practice up on Canvas for you. Now, what conditional probability, I have a sort of formal definition here. Basically, it's like probability that one event occurs given that another event already happened. And we're not worried about that other event that already happened, but just the way that it impacted the event we're looking at. So for the example, the probability of having a heart attack if someone in your family has already had a heart attack. I'm not worried about all the people in the world, because I'm focused on, a select group of people, that given part. Now with conditional probability, there is some notation to be aware of. When we sort of specify the probability that we're finding, both events are listed, and you'll see this sort of line here in the middle. And so if I'm reading this sort of probability statement, it would be like, what is the probability that a person has a heart attack given? And so that line represents, the given that a family member has already had a heart attack. Now, if we're using that in sort of generic notation, you might see it written as like the probability of event A given event B has already occurred. Now, if I'm describing what's going on in this case situation, in the top of my probability fraction, what we're going to see is basically the number of times that you have the overlap that both event A and B happened. So this would be like the overlap. So like the number of times A and B happened. But the difference is like it's given that event B happened. So my denominator isn't like the total number of possible outcomes in the world. It's instead sort of the number of times B alone occurs. So that's my way of thinking about it. As usual, I'm going to give you sort of the formal formula. If you were to Google this, you would see it written as sort of the probability of A and B divided by the probability of B. And that's really the same thing that I'm describing. It's just another way to think about it. And it seems really complex, but if you sort of focus on that general idea that I was talking about up top, the number of times A and B, so it's like I'm looking at the overlap and then I'm looking at event B. It makes it somewhat simple. So we're going to start with a Venn diagram. So we're going to look at a Venn diagram, and then we're going to also look at a contingency table, and we're going to do these examples out, and then you'll have one to try on your own. So we have a group of 20 students. They were surveyed about their chocolate preferences, milk, dark, or white chocolate. 12 of the students preferred milk chocolate total, while 4 only liked milk chocolate. 5 of the students did not like milk or dark chocolate, preferring white chocolate. So we're going to have a 5 on the outside. Those are my 5 who didn't like milk or dark. Now, 4 liked only milk. And I should have a total of 12 in that milk chocolate circle, which means 4 plus something equals 12, so that would be 8. And I had 20 total students, so 12 plus 5 is 17, which means there are 3 students who only like dark chocolate. So a little bit of review with building a Venn diagram there. Now, let's stop and focus on this first one. So we want, what's the likelihood that someone likes milk chocolate given they like dark chocolate? So I start with the second term. So we know the person has to like dark chocolate. That means we are ignoring most of our Venn diagram, and we are only focusing on people in the circle I've highlighted in red. I don't care about anyone else, which means I only care about those 11 kids. Of those 11 kids, 8 liked milk chocolate. So it's like the number of the people who liked dark chocolate who also liked milk chocolate was 8. So my overlap, so, sort of think of that as your overlap. And then the down below number was the number of dark chocolates. So do you see why we did all that practice last week? Now, if we flip that around and we now are saying, okay, I want how many people, what's the probability that someone likes dark chocolate given they like milk chocolate? Well, this time, we're looking at the outcome of milk chocolate. Well, there were 12 people who liked milk chocolate. And of those 12 people, 8 of them also liked dark chocolate. So notice now we've changed our sample size. That second value is giving us sort of our sample size is a way to describe that. Size. I'm not going to turn those into decimals for now. We've had a lot of practice with that, so we're sort of focusing just on that sort of unsimplified fraction, and can we come up with the interpreting the notation. All right, so let's look at another diagram, and in this one we're just going to put together all our probability methods in one question. So we have the American College Health Association asked the following question: within the last 2 weeks, how many times have you had 5 or more drinks of alcohol at a sitting? And so you'll see the number of drinks and then classified by gender, male or female. And I know they didn't give a non-gendered option. This was a older survey. And so all we're doing is we're sort of figuring out the different probabilities based on what they're given, and doing a little bit of interpreting from those contingency tables. Now, this is something similar to what you're going to need to be doing on your group discussion project this week, in which you will be picking out a contingency table like this one and then writing some probability questions. What a coincidence. All right, so probability that someone is male. Now, with a lot of these, our total is going to be that sort of total sample size. And so for these first few ones, I'm looking at, okay, total number of people who are male in this survey were 8,956 out of the 27,268 who were surveyed. And that's my probability. Turn that into a decimal, but for now, we're just going to leave it as the fraction. If I then wanted 0 drinks, I would go over to that total number of 0 drinks, and so that would be 18,712. And again, still out of our total 27,268. You're like, okay, makes sense. All right, now let's look at an and probability from a two-way table. So we have 3 to 4 drinks and female. So if I'm looking at this, then I would go over and I'd say, okay, well, here's my row with 3 to 4 drinks. So let me pick a different color. And then here's my column for female. And I want the overlapping number, which is 966. But it's still out of my 27,268. Now, I didn't put it down here, so we're going to add a question. What would be the probability of, instead of an and probability, what if we made that an or? So we had 3 to 4 drinks or female. So this is like an either or situation. So remember, we did stuff like this last week. And if I were focused on it, what I would do, and I'm going to do a little bit of erasing here, I would go through and just look at my numbers. Then I don't have to worry about my formula. And so it's like, okay, I have, this number and this number. So those would be my 3 to 4 drinks. And then those would be all my females. And so I just need to add up all 5 of those numbers together, and I would get 19,224. And that's still out of my total 27,268. And that way I didn't have to worry about overlapping. I just sort of added my individual boxes. It's similar to how I approached the Venn diagram problem. All right, so those are all our previous types of problems. Now let's turn and we're going to focus on our conditional probability. So on the first one, we're saying, okay, we are saying, given that someone has 0 drinks, okay, that means I am going to ignore all of my table except the 0 drink row. That's the only part of my table I care about. And of that, what's the likelihood that they are male? And so if I'm then listing out this probability, there are 5,402 males that had 0 drinks in a week, and there were 18,712 total people. And so that would be my probability of picking someone who was male, given that we're only focused on 0 drinks. All right, next one. We're saying, okay, what if they're female? How many of them are 5 or more drinks? So this time we're only going to focus on this column, and specifically the 5 or more drink number. So if I write that up as a probability, there are only, 18,312 people I care about this time. And of them, we're looking for the 358 who had 5 drinks or more in a situation. And so this is an example of how we use our contingency tables to do all our types of probability. And so we're sort of building off of what we did in the previous week. Notice, in the previous week we had to come up with those number counts. And so now we're turning them into probabilities. On the next sort of slide in the presentation, you'll get a chance to sort of try this again with a slightly more complex maybe contingency table. And then we got a bunch of questions to answer on it. And hopefully, this gives you sort of a general overview of probability to give you a leap start on your practice this week.